Day 1 of Phase 2 on the Stanislaus River. Phase 1 AquaDam has been removed. The new concrete spillway intake is in place, and we will be installing AquaDams against the face of that overflow weir, coming back upstream and reaching the bank somewhere over there. This will isolate the original existing concrete dam intake structure so they can remove it without causing turbidity or discharges into the water. The plan here is to start the 16-footer off the weir over there. 3-inch discharge gas-powered water pumps are being set up with suction hoses and a secondary containment area. These pumps will be used to fill up the 8-foot tall AquaDams as well as the final 16-foot tall AquaDam. Three pumps into the outside of the AquaDam, one pump onto the inside. That means left and right. One pump on the left side tube, 3 pumps on the right side tube. And that will cause the AquaDam to fill unevenly, making it turn. And on shore, there are men holding back the rope, which is influencing the AquaDam in the direction that we want to go. The 8-foot AquaDam is being tightly controlled with a series of rope. We are pumping only into the outside tube, the right-hand tube, in order to facilitate this turn. Once we make the turn, we will fill both sides of the AquaDam evenly. It is currently being pulled over by ropes attached to the bottom seam under the pipes to where this worker is. These ropes will be tied off to these large sandbags and hold the bottom seam in place until the AquaDam unrolls over it. The 8-foot tall AquaDam, stop pumping on it. We're holding back the roll, and we're attaching another tie-off rope to the bottom seam to the existing concrete intake structure. The 8-foot tall AquaDam has been fully inflated and fully unrolled. It is installed into much deeper water than it normally would be. Not much is showing above water level. The reason that it's okay to install this AquaDam into water so much deeper than what it's rated to control is because we're not dewatering one side. As long as the AquaDam is 1 inch higher than the surrounding water, it will not be influenced by external currents. If we tried to dewater one side of the dam, then it would start to list and take the pressure of the external water pressure. 2 excavators are moving the 16-foot tall, 255-foot long AquaDam. We will start with a double close ended up on the wooden weir. Begin filling the AquaDam, unrolling it upstream around the work area. The outer wrap is being cut off, and the unwrapped AquaDam will be set into the water to float into position. We will pull this back to shore and attempt an installation tomorrow from the shore towards the weir. Second day of the Phase 2 AquaDam installation. We have retrieved the 16-foot tall AquaDam from on top of the weir and brought it along shore. Now we are pulling the fill tubes up and over. We will be installing an 8-foot tall AquaDam today alongside the 8-foot tall AquaDam that's already been installed. And tomorrow we'll be installing the 16-footer. The 8-foot tall AquaDam has been rolled down the slope. The fill tubes have been exposed up the slope. This AquaDam, 8-foot tall, approximately 150 feet long, is buoyant in the water because there's no water inside it. And the material it is constructed of is slightly lighter than water, so it floats. We're connecting hoses, and then we will begin pumping it. We've tied off the closed end over here to the bank, as well as up to the shackle on the strap holding the log upstream. That will hold the AquaDam in place as we fill it up. The first 20 feet or so necessary to hold the AquaDam in place. The AquaDam is very close to the end of its roll. The closed end of the AquaDam has been tied back. The 8-foot tall AquaDam spill tubes are being arranged so that they stay at a higher elevation than the rest of the bag. This keeps the water inside the AquaDam. Now that the second 8-foot tall AquaDam is installed, we are preparing the fill tubes of the 16-foot tall AquaDam. Multiple discharge hoses and suction hoses are being placed in the fill tubes. These will all be used to fill the 16-foot tall AquaDam. This is the open end of the 16-foot tall AquaDam. There are 2 fill tubes side by side. They have the white inner plastic, and our discharge hoses are being fed into these fill tubes. Getting water into the fill tubes is key for filling the AquaDam. The 16-foot tall AquaDam is being tied off to the upstream log. This way we'll have a tie-off point, which is directly upstream of the AquaDam, making the turn time much easier. The blue and white buoys mark the outside edge of the AquaDam. The 16-foot tall AquaDam is tied off in several places, back to the log, as well as through a pulley, and back to the truck. We're going to position the AquaDam where we want it. Currently, we are only pumping into the right-hand side tube because that will be on the outside of the turn. We want to fill that tube up first. We are replacing the ropes and tying them back to a ring rope, which goes around the circumference of the AquaDam. Once the AquaDam goes over it, it's basically a tie-off point now. We've already isolated one half of the weir. All the flow is going to the other half. This side is dry. The AquaDam has been restrained from unrolling, and a head has quickly built inside the AquaDam. AquaDam's completely unrolled, and the closed end is about 2/3 of the way across the top of the weir. The AquaDam installation is complete. The 16-foot tall AquaDam just needs to be brought up to its full height. The backup 8-foot tall AquaDam is in place behind the 16-footer. And the 8-foot spacer dam over here will be removed at a later date. Water is draining in the work area. The AquaDam has diverted the flow to the right side of the weir.
Well, we almost